This is a peer tutor problem E from the study guide, unit 7, circles. Keep in mind as you teach this problem, a good peer tutor pesters. Your job is to create dialogue and do not dictate simply the answer. You should be asking more questions than give answers. You should elect your quad mates to read aloud the problem. In other words, the person you are tutoring, force them to read, them to answer questions, etc. You are their coach. You are simply not dictating the answer. So let's take a look at problem number E here. It says a circle has a center of -1, 1. And the endpoints of a diameter are at S, -5, 3. That should be comma there. And T is at 3, -1. Graph on the grid to the right. You're going to use a ruler to graph a line that is exactly tangent to circle Q at point S. You're going to darken the radius QT. We're going to find the slope of the radius QT. You're going to write an equation of a line that is tangent to circle Q and passes through point S in slope-intercept form, y equals mx plus b. So taking a look here, now for right now that sounds like a bunch of mumbo jumbo, but keep in mind some basic things here. You're going to show your work below and an equation of a circle. Let's just take this one step at a time. First off, it says right here, circle Q has a radius of -1, 1. So let's start by plotting that. -1, 1. That's circle Q. We know that means Q is the center of the circle. And it has the end points of the diameter, -5, 3. That's S. And the other end point, 3, -1. Now, we know that's a diameter, which means it goes from one side to the other, all the way across, creating a straight line. So I'm going to do this, one side to the other. Let's create a straight line. That's a diameter. Now, we're actually going to we want to find the equation of this circle. So we're going to work kind of bottoms up here. The equation of a circle, of that circle. It's easier to graph. So let's start by writing the equation of a circle right here. That's the x minus h squared plus y minus k squared equals radius squared. Now, there's only two things you need here. You need a center, which is your HK, and you need a radius. So let's look at what we've been given. We haven't actually been given our center. Our center is -1, 1. That's our HK. If we didn't have our center, we would use the midpoint equation to find the middle of the diameter. But we do have our center, so we already have our HK. What we don't have is our radius length. So we're going to find our radius length using the distance equation. So I'm going to find the distance between QS. So you start by making a template. I'm going to pause so that you can catch up here. I'm going to go ahead and put our numbers in. Q is going to be at -5, -1, that's our x's. And that's going to be 3 minus 1. Double negative makes the positive here. So I'm going to end up here with -4 squared. And that's 3 minus 1, so that's 2 squared. That's going to be 16 plus 4. That means our radius is actually the square root of 20. We're going to leave it under the radical sign there. So our radius is going to be square root of 20. Which means my equation, x minus the center of the circle, which is -1 squared, y minus 1 squared equals root 20 squared. Now we clean it up a little bit. Our final equation here is going to be x plus 1 squared, y minus 1 squared, and root 20 squared is 20. And the question is, how on earth do we graph root 20? It's not rocket science. You actually get to use a calculator here. So we're going to do 20 square root. We're going to round it to the first decimal place, and we see that it's approximately 4.5. So to graph this line, we're going to go up 4, 1, 2, 3, 4 and a half, down 4, 1, 2, 3, 4 and a half, right 4, 1, 2, 3, 4 and a half, left 4, 1, 2, 3, 4 and a half. Now you have your guide points plus your diameter lengths here, so you can graph your circle. Go ahead and swing that around. So let's take a closer look at what you have here. So right now what we have is we have S and T are the diameter, Q is the middle. Now what we want is we want the equation of a line ultimately that is tangent to circle Q and passes through point S. Tangent to circle Q and passes through point S. It also asks you to darken Q to T. Let's start by doing that. We're going to darken Q to T. And we are asked to find the slope of QT. We're going to go that right there. So to find the slope of QT, we're simply going to bunny hop it. Ready? 1, 2, 3. 1, 2. Whoops, that's not 3, it's 2. Let's go this way. So we can see here that our rise is going to be 2 and our run is 4. But look, it's a negative line, so our rise 2 over 4, and it's a negative line, therefore our slope of QT is going to be negative 1 over 2. All right, our goal is to find the equation of a line that passes through point S, which is -5, 3, that's S, and is tangent to circle Q. Well, how about we physically draw that and see what happens here? And is tangent to circle Q. So let's draw a line that is tangent to circle Q at point S. Remember, if we're tangent, technically at point S, that's a radius. So we know this, if tangent to a radius, radius of tangent to a radius, right angle at the edge. So when we draw this line, there's going to be a right angle here. That's really important because that gets you your slope. Our slope of the radius here is -1/2. The slope here is perpendicular slope, and we know slope times slope has to equal -1. So it's -1/2 times something is -1. We want the equation of this line. And we know its slope must be 2/1. So we want, it's going to be tangent. That tangent gets us the slope of what we want. Because if tangent to a radius, right angle at the edge, we know our slope that we have to work with is 2/1. And we want it to go through this point. Let's look at what we have. We have slope. Circle X, we actually have X right there. Circle Y, we actually have Y right there. Your job is to solve for B and then write that equation. Y equals mx plus B for that line. Okay, you're going to have to finish this yourself. Solve for B. And then you want to write a y equals mx plus b. And once you have b, you're going to put it right in there. You already have your slope, and that's going to go right there. And your equation should match your diagram.